Welcome to Organic Chemistry. My name is Dr. English. Today we're going to talk about naming organic compounds with double and triple bonds. We're going to start out with compounds with double bonds, then talk about double bonds with branches, compounds with triple bonds, and then finish it up with some general rules. Steps for naming organic compounds with double and triple bonds. Naming organic compounds that have a double or triple bond is different than those compounds that contain only single bonds. So consider the saturated hydrocarbon below. And we know that it's saturated because if we look at all the individual bonds in between, like right here and here and here, we can see that they're all single bonds. That's why we classify it as saturated. So the name of this hydrocarbon would be, if we counted all of the carbons, and there's 1, 2, 3, 4, 5, 6, so it would be hex, and then they're all single bonds, so this would be hexane. So the name of this hydrocarbon is hexane. Now let's change the compound to look like this. The compound contains a double bond, and where is that double bond? It is right here. We need to modify the suffix of the parent chain to reflect the presence of the double bond. The ending of this compound will now be ENE. Location of double bonds. The location of the double bond also needs to be identified, similar to that of branching chains. In the same manner, we will number the carbons starting at the end closest to the location of the double bond. The carbon number assigned to the double bond is the first carbon, and that's really important. The first carbon encountered in the chain. So let's look at our molecule. So we need to ask ourselves, if this is my left and this is my right, what end should we start counting from? And we need to take into account that our double bond needs to have the lowest possible numbers associated with it. That means I'm going to start counting from the right. So this would be carbon 1, 2, 3, 4, 5, 6. Which reaffirms that we are dealing with 6 carbons, so it is going to be hex. We know that the ending is going to be ENE, but the double bond is between carbons 2 and 3. So when I write this, I'm going to put 2 dash hex, and then the ending ENE for hexene. That 2 indicates that the double bond is starting at carbon 2 and going to carbon 3. What would happen if we moved the double bond to a different position? So again, we have to ask ourselves, if this is my left and this is my right, which end should we start counting from? And again, we're going to start counting from the right. So this is carbon 1, 2, 3, 4, 5, 6. It's still hex, it's still ENE because we have our double bond right here. But now, to indicate the location of that double bond, we know that it starts at carbon 1. So the proper name for this compound would be 1 dash hex, and then the ENE ending. So because the double bond is between carbon 1 and 2, it's 1 dash hexene. Double bonds and branching chains. What would happen if we had a hydrocarbon with a double bond and branching chains, like we do in this scenario? So let's look at this. Here is our double bond, and we have a methyl group right here, and we have another methyl group right here. Because 2 methyl groups are attached to the third carbon atom, the correct name for this branching alkene would be, well, let's figure that out. So this is my left and this is my right. It turns out that double and triple bonds are going to overrule branching chains. Even though it really doesn't matter for our branching chains here because they'd both be 3 no matter what because they're smack in the middle, I'm going to make this carbon over on the left carbon 1, 2, 3, 4, 5. So it's 5 carbons. So we know we're going to use the prefix pent. The ENE will be our ending, so it's pentene. We have 2 methyl groups, so that's going to be dimethyl, both coming off of carbon 3. So the full name for this compound would be 3, 3 dimethyl dash 1 dash pentene. And that gives us all the information to reconstruct this molecule. We have 2 methyl groups coming off the 3rd carbon, so that's our 3,3 because each branch needs a number associated with it. 3,3-dimethyl. The double bond is between carbons 1 and 2, so it's 1. And then finally, 5 carbons, that's pent, double bond, ene. So 3,3-dimethyl-1-pentene. Now let's talk about triple bonds. Naming triple bonds follows the exact same method as double bonds. The only difference would be that the suffix of the parent chain will now end in YNE. Consider the unsaturated hydrocarbon below. So again, the first thing that we always need to do is look at where the triple bond is located and decide where to start numbering our carbons from. And in this case, it really doesn't matter because, again, it's right in the middle. So I'm going to start over on the left, and I'm going to call this carbon 1, 2, 3, 4, which means my prefix is going to be but. It's a triple bond, so my ending is going to be YNE, and the triple bond falls between the 2nd and the 3rd carbon. So this is going to be 2- but, and then the YNE ending. So 2-butyne. What if we changed it to look like this? Now this is important about where we start numbering our carbons. So this is my left and this is my right. We know we need to start counting from the left because the triple bond is closest to the left-hand side. So 1, 2, 3, 4. Still but, still YNE, but now it's going to be called 1- but, and then that YNE ending to indicate the triple bond. So 1-butyne. So the general rules are, if more than one type of branch is present, the names are arranged in alphabetical order in front of the name of the parent chain. If a compound contains both branches and a multiple bond, like a double or a triple, the carbon atoms are numbered so that the carbon with the multiple bonds has the lowest possible number. So what did you learn? We talked about compounds with double bonds and branches, compounds with triple bonds, and then some general rules. Need more help? Feel free to contact me. Have a great day.